This video is going to cover Chapter 12, Section 3, and we're going to be finding probabilities using combinations. So just to recap, in Lesson 12.2, we covered permutations. And a permutation is when order matters. So what's going to happen is we're going to try to find the difference between a permutation and a combination. The key difference, again, for permutation, when we're arranging our items or our things, the order of the arrangement matters. When we see the combinations in this lesson, order will not matter. So key phrases that you'll be looking for is when it's a permutation, it might say, in how many ways can I arrange something or order something. The order of people winning a race, that would be a permutation. Or if I wanted to order letters of a word. Those are all examples of permutations. So let's first see what a combination is. So a combination is a selection of objects in which order is not important. It's used when drawing for identical prizes. Okay, again, order does not matter when it's a combination. Order matters when it's a permutation. So let's take a look at our first example. And it's asking us to count the combinations of two letters from the list A, B, C, D. So we're going to go ahead and make our organized list. We're going to first start with the letter A. We know we could put it with the letter B, the letter C, and then the letter D. Now we're going to switch to the letter B. And we can put it with, we've already put it with A, so I don't want to repeat that, but I can put it with C, and I can put it with D. Now we're going to move to C. And notice we've already put C with A over here. And we've already put C with B over here. So the only thing we have left is C with D. And now if I go back and count these, there are 6 combinations, taking 2 letters out of those 4. Next, we're going to see the combination formula. Now, it looks very similar to our permutation formula. The only difference is we're now adding in this R exclamation point in the denominator. So everything else is exactly the same what we used in the permutation formula. Now, because we're dividing by another number or several numbers, it's going to make us have a smaller answer. So there's always going to be fewer combinations than there would be permutations. Let's look at another example. So here it says you order a sandwich at a restaurant. You can choose 3 side dishes from a list of 8. And it wants us to find out how many combinations of side dishes are possible. Now, when we go to set this up, our N value is always larger than our R value. So the 8 is our N value and the 3 is our R value. So I'm going to use my notation in the formula that I just saw in the previous slide. So I'm going to be doing 8 factorial over 8 minus 3 factorial times the R factorial, which is 3. So now I'm going to go ahead and I get 8 exclamation point. 8 minus 3 is 5. And then 3 exclamation point. And now I need to expand this out. So I'm going to do the work down here. So what I'm going to do is I'm going to bring the 8 down until it gets to the 5 factorial. Because I'm going to take this 5 factorial and I'm going to write it right below it. I'm going to move it over there. And then the 3 factorial, I'm going to expand. 3 times 2 times 1. And now I'm going to simplify things. I can simplify the 5 factorials, and then I could also simplify the 3 times 2, it equals 6, and now my final answer here is 56. Now, there is a button on your calculator that will do this. Again, I highly recommend that you search for something on Safari or Google based on the type of calculator you have. But generally, you're going to be looking for PRB usually. If you have a graphing calculator, you're going to touch the math key, and then you're going to scroll over until you see PROB, and then it lists all the different options. So again, look for these. There should be a probability key, and it's going to open up everything, the factorial, the permutation, the combination, or you can always do it by hand. Let's try another example. Here we have a yearbook editor, and they has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. It wants us to find the probability that your photo and your friend's photo are the 2 placed at the top of the page. So the first thing we need to do is find out all the different combinations of the 14 photos chosen 2 at a time. So my N is going to be 14 and my R is 2. So I'm going to use this formula to find all the different combinations first. So 14 factorial over 14 minus 2 times 2 factorial, 14 factorial over 12 factorial times 2 factorial. I'm going to go ahead and expand it out. 14 times 13 times 12 factorial, because again I'm going to write this 12 right underneath it so I can cancel it, and then I'm going to take the 2 factorial and expand it. The 12 factorials cancel, and then I can also cancel 2 will go into 14 7 times. So 7 times 13 is 91. So there are 91 different combinations of those photos. Now the question didn't ask for combinations, it asked for probability. So what is the probability that my picture or your picture and your friend are going to be up at the top? So again, we always know the total is in the denominator for probability, and then there's only one combination of a picture of me and my friend, so that would be 1. Let's do another one. Here it says, your teacher randomly chooses 2 out of 18 students to give an impromptu debate on freedom of the presses in high school newspapers. Again, it's asking for probability that the teacher chooses you and your best friend. So first, let's find all the different combinations. So we have 18 students and we're choosing 2. So 18 factorial over 18 minus 2 times 2 factorial, 18 factorial over 16 factorial times 2. And again, let me expand it out. 18 times 17 times 16 factorial. Move this 16 underneath so I can cancel it, and then expand the 2 factorial. This is going to cancel. I can also simplify the 2 and the 18, change that 18 to a 9. So 9 times 17 gives me 153 combinations of 2 students chosen out of the 18. Now again, it asks for probability, and again, just like before, there is only one combination of me and my best friend. So for probability, it's going to be 1 over 153. And one last example, and this is easy, it's just the symbols. So again, if you find this on your calculator, you can just quickly key it in, but I'm going to do it the long way. So it's 10 factorial over 10 minus 8 times 8 factorial, 10 factorial over 2 factorial times 8 factorial. I'm going to take the 10 down until I get to 8 factorial, write the 8 factorial underneath, and expand the 2. So again, these are going to simplify. Those will cancel. And then I can also simplify the 2 and the 10 and make that a 5. So my final answer here is 5 times 9, 45 different combinations. Now the next one, this one's kind of large. 24 factorial over 24 minus 10 times 10 factorial. 24 factorial over 14 factorial and 10 factorial. I'll write it below here. So I'm going to take the 24 all the way down till it gets to the 14. 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14. I'm going to stop there. 14 factorial. Those simplify. Now I need to expand the 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, again, if you have figured out how to use the button, it makes it a lot easier. Now, if you weren't using a calculator, you can look for different things to simplify. Like I could do 10 times 2 and cancel out the 20. I can do 9 goes into 18 2 times. 8 goes into 16. Let's actually do 8 times 3 is 24. And then I could do the 7 and the 21 and make it a 3. And I can do the 6 with this 2 and 3. I can do the 5 and change the 15 to a 3. And then I could do the 4 and the 16. And then now I would multiply what's left, the 23 times 22 times 19, 17, 4, and 3. And this is going to give me 1,961,256. So again, it makes it a lot easier if you can find the button and figure out how to do this probability on your calculator without having to do things like this, or even just multiply and not simplify. So that is it for the notes on 12.3. So go ahead and complete the 12.3 homework and also the 12.3 warm-up.